Here are solutions to homework set number 8 for ECE 341 random processes. In this homework set, we're looking at gamma distributions and normal distributions. Now, the first problem is suppose D is a sample from an exponential distribution with a mean of 5. What is the PDF of D plus D plus D, meaning the first time that 3 events happen in D? Well, the PDF for D is exponential, 0.2 e to the minus 0.2t. 0.2 is 1 over 5. The Laplace transform is 0.2 over s plus 0.2. When you combine 3 properties or PDFs, you can involve them, or you multiply the Laplace transforms. So that'll just be 0.2 over s plus 0.2 cubed. If I take the inverse Laplace transform from a table, 2 over s plus b cubed is t squared e to the minus bt u of t. So putting the same form, I'll have a 2 over that plus times a constant. So it's 0.2 cubed over 2, t squared e to the minus 0.2t. And here's what that looks like. Problem 2 is use moment generating functions, i.e. Laplace transforms, to find the PDF of e plus d plus e plus f. So again, you convolve in the time domain, you multiply in the Laplace domain. So multiply the Laplace transforms together, do partial fraction expansion, and what you wind up with is 0.1 e to the minus 0.2t minus 0.4 e to the minus 0.1t plus 0.3 e to the minus 0.06t, which looks like this. Problem 3 looks at a normal distribution. Here is the temperature, high temperature, this is the low temperature in Fargo for each month, mean and standard deviation, based upon data from Hector Airport. From that, what's the chance we'll have a killing frost in May? As the temperature drops below 30 Fahrenheit. Well, to do that, I find out how far is 30 from the mean in terms of standard deviations. It's 0.58. The average low is below 30, so the probability is to be more than 0.5. So make that a plus 0.58. Throw that in a normal distribution. Find the probability corresponding to that z-score, and it's 0.72. And again, it's bigger than 0.5 because 30 is above this, so there's more than 50% chance it'll freeze in May. Turns out about 58% chance we'll have a killing frost in May. On the month of June, the average temperature is 42, or 40.2. Killing frost is 30, so how far is 30 from 40 in terms of standard deviations? Is 2.53 standard deviations away. So I want to find the area of the tail. 2.53 deviations away gives you minus 2.53. Area of the tail is 0.0052, so that's the probability of getting a killing frost in June. In July, the average low is 46 degrees, standard deviation is 3.9, so the z-score is how far is the low from 30, the mean. How far is 30 from the low? Try again. How far is 30 from the mean in terms of standard deviations? It's 4.12 standard deviations away. And the area of the tail is 0.00002. Can happen, but unlikely. Rainfall. If I combine 3 months, and this is the case of June, July, August, when I combine normal distributions, the means add and the variance adds. So adding the means, I get 9.12. Adding the variance, taking the square root, I get 3.35. For 10 inches of rain, the z-score is 0.2617. To find the tail, it's how far is 9.12 from the mean in terms of standard deviations. It is 0.26 standard deviations away. Actually, how far is 10 from the mean in terms of standard deviations? Area of the tail is 39%. And finally, what's the chance that we'll have no rain over the entire summer? Well, to do that, you add the means, add the variances, The average rainfall in summer is 15 inches with a variance of 18. Take the square root, that gives you the standard deviation. Again, the standard deviation doesn't add, it's the variance that adds. So to find the probability of 0 is how far is 0 from the mean in terms of standard deviations. It's 3.64 standard deviations away. Going to StatTrak, 3.64 standard deviations has a tail of 0.00013. About 6,000 to 1. Can happen, but unlikely. That is homework set number 8.